Hello class. That last video ended rather abruptly. I did not see that ending coming, but that's okay. Finished it up, and then this will be the second half, the last half of fluids and electrolytes. So to review a little bit, you can see fluid intake and loss. Remember that's just, approximate percentages that where our water, in this case, our water comes in and how we lose it. Again, each one of these variables can differ, but this is on average, right? Most of our fluid you can see comes in from our water that we drink, liquids that we drink, and food. Most goes out in the urine. Yes. So we'll continue talking about this, about some electrolyte imbalances, and we'll talk quite a bit about your pH. This is an albatross. I took this in the Galapagos, this picture, and you can see it's got some crystals coming out of its nostril and going down its beak like that. What is going on? Well, these birds are amazing. They may never drink water, fresh water. They can spend their whole life in the southern hemisphere just flying around. They don't need a lot of energy because there's high winds. They use the winds, and they eat fish. And they only come to land to lay their eggs. They're really awkward on land. They can't even take off from the ground. They need these cliffs so they can dive off and be able to fly. But what does this mean? Well, if they can't have any fresh water, it seems like it'd be an issue. Well, what you see coming out of that beak is salt. And so they have a mechanism that we don't to get rid of salt. They have these glands that use energy, it takes ATP to extract salts from their blood and then make a highly saturated saline solution that will just come out their nose. And Galapagos iguanas that live there, they will sneeze in this big plume of looks like steam, but it's water comes out, highly salty water. They'll get rid of salt that way. So if you guys are trapped on the ocean, water everywhere, you can't really drink the seawater because you end up, it gives you so many more electrolytes, it's going to end up dehydrating you, and getting rid of them is going to take more water than you're going to take in. So one of the great sad paradoxes there, being surrounded by water. And so looking at it, you can just imagine how something like this would work. You're going to be pumping from lower to higher concentration. You're going to try to highly concentrate the salt. That takes energy. It doesn't want to move that direction, right? So you have cells that use energy to pump the salt and concentrate it in these tubes, and therefore you can get rid of it that way. So salt glands are something that you see in various animals to get rid of excess of salt. So dehydration, obviously something very important that all you should be aware of. It's important to stay hydrated for many reasons. And the causes, again, can be many. It can be not drinking enough water, you think is obviously, but maybe water's not available. Or maybe you're excess sweating, or even vomiting, or in many cases, the diarrhea, and kids will quickly be dehydrated if they're getting rid of fluid in their waste, right? And so what happens, of course, is the less water, the more dehydrated you get, your fluids in your body become more concentrated and more salty. And of course, in your hypothalamus, the cells will shrink, and then they'll be sending the signal for ADH to kidneys, do not lose that water, hang on to it. And it'll make you thirsty, so you'll be searching for water. And if you continue to be dehydrated in a hot environment, eventually you can't sweat. And then there comes a point where you stop sweating and your temperature is going to skyrocket. And you guys should know, make sure you know that if you're over 104 degrees, something like that, around there, Fahrenheit, you're in real danger. And above that, your proteins denature, and there's no going back. It's like trying to on-fry an egg. So your proteins just, that's it. So overheating is a critical issue. You guys can cool down. We can cool you down way below 98.6, but once you get above, you're going to die if your fever gets that high. Yeah, and this shows also, some of the signs of dehydration. You'll see that your skin won't snap back quite as quickly. We'll see this in babies here. I'll talk about it. Yeah, so looking at dehydration, if you don't have enough water. Here's some things that, if you have tonsillitis or other pain in your mouth, you can't swallow, then you're not going to get enough water. But, in many cases, you don't have access to water. You're trapped in that life raft in the middle of the ocean. Or often in athletes, and you'll have tragic cases. They're working in extreme heat and they don't hydrate enough, or do a long race, they don't drink enough. Or you're in the military and you're in the desert and you don't get enough water. All these things are going to contribute to that. Not enough intake. Fluid loss, look at this, definitely. Hot climate, definitely. If you're just vomiting, you're getting rid of fluid. Or on the other end, diarrhea. On the other end, getting rid of lots of water. I see here they mention even diabetes. There's diabetes, a couple kinds of diabetes, but if you're getting rid of so much sugar, it's called, by osmosis, the sugar is going to take the water with it too. What do I have here? Oh yeah, here it is, diarrhea. All these things that could cause you to just lose fluids from your waist, and then you become more and more dehydrated. And it gets serious, they want to hook you up to an IV bag, right? If it's not that serious, just drink a bunch of water with electrolytes too. You got to replace those. Pure water is going to cause some issues that we'll talk about next. And so looking at dehydration, what are some of the signs? And what are you going to see? I'm looking at dry lips, or your mouth will become dry. Yeah, looking at this baby here, you can see that fontanelle, that soft spot, I mentioned this, will be sunken in because you have less cerebrospinal fluid too in the brain. That'll be sunken in. The skin, again, won't snap back. You often see a very rapid, shallow heart rate, shallow pulse. Definitely shallow breathing. Some of the signs. And again, infants are really at a really dangerous situation because they actually have less control of their kidneys with the ADH, and they have a smaller amount of fluid, so you can see how that would become dangerous quickly. But looking at some of these symptoms, you can just take a look at them. Definitely dehydrated. You stop producing urine. Your blood pressure is going to go down because you have less body fluid. Your eyes can be sunken because the fluid in there. Pulse becomes low but rapid. Yeah, breathing. All these things. And mental state too. When you get really dehydrated, you'll start out with a headache and you become more lethargic and issues like that. Now, believe it or not, you can overdose on water. Everything. And then, just as an aside, every chemical is toxic. It just depends on the level. So people talk about, it's just toxic. That's toxic. Well, salt water is toxic. It's a matter of dose for everything. So when you drink too much water, and your book paints the picture of sometimes these long races, the marathons, you'd have people dropping dead, and they found out that they're so diluted, which is going to really dilute your electrolytes. There's so much water because they drunk so much, because it was said just drink as much as possible, right? But it turns out that's not the case. And runners, you should actually weigh yourself with a good scale, do a typical workout, weigh yourself after to see how much water is lost, and just replace that amount so you're not overhydrating. Water intoxication, water overdose, technically is called hyponatremia. Now, natremia, sodium, right? And hypo is not enough. So why don't we call it like hyperaquia or something? We don't. Hyponatremia just means that you're so much water that sodium, which makes up 90% of the electrolytes, right? It becomes very dilute, and will kill you, right? So hyponatremia is too much water from, like, again, athletes can take it trying to compensate for, they know there's going to be water loss, or they have this stupid hazing that's done where you just drink, make them drink all this water, and it can actually cause hyponatremia and death just from, starts out as a simple prank. So that happens too. And what actually is the issue, as you can see, is that if you dilute the extracellular water, it's going to rush into the cells by osmosis and cause them to swell. And your brain swelling and these cells, you can imagine, is not good. So, too much water. We keep talking about not enough, but too much water will cause death, hyponatremia. Hypernatremia would be too much sodium, and that can happen as well. Usually you can have some kind of kidney problems doing that. I mean, you can eat too much salt. That sounds like a horrible way to die, but your kidneys will try to get rid of it. But if your salt levels get too high, you have hypernatremia, it's going to cause problems. Just like hyponatremia is going to cause problems. It's got to be right in that range. And the other word I want you to know, just be familiar if you're here, hypo and hyperkalemia. That means potassium. So too low or too high levels of potassium can also, either way, will cause serious issues. And there's many causes that can cause this that I don't need to get into, but your sodium would be natremia, and your potassium would be kalemia. It can be hyper or hypo. I have to mention this because you will see, oh my God, I saw some commercial they're talking about, it was Gwyneth Paltrow or something talking about, oh, we drink this alkaline water and we put a slice of lime in it, and oh my God, you're adding acid, so you're neutralizing anyways. You'll hear a lot of this talking about your body's pH, because it's kind of a new thing. But realize, this just shows you that whether you drink or you eat, your body's pH is within this narrow range. You can see this dead, right? So, eat a balanced diet, all right? And trying to alkalize or acidify your body is just a fool's errand. All right, so there's acid base. We'll talk about pH here. Why is it important? Why does your pH have to be between 7.35 and 7.45? One other thing, I know I'm saying it sounds like a narrow range, but this is a logarithmic scale too. So anyway, but didn't mean to minimize it there. Turns out when you look at chemical reactions, maybe you guys in chemistry, like you had to put a buffer in the test tube. It's because it has to be at a certain pH for the reaction to happen. Well, definitely. That's what it's about. Our chemical reactions, we've evolved for it to be most efficient in that narrow range. And once you get too acidic, you got hydrogen ions that are screwing up the reaction, or the opposite. So our pH needs to be in this narrow range. Yep. I'm just asking you guys, because we just studied this, the best way, the easiest way to change your body's pH is what? Breathing, right? You can hyperventilate or hold your breath, and that's going to change your pH, because carbon dioxide is the big thing, turning into carbonic acid, right? Yep. So hydrogen ions, this acidity, it turns out our pee is usually acidic because our metabolism, we're usually getting rid of acids. And just breaking down our glucose, right? Hydrogen ions, they're going to turn into water here, but carbon dioxide that comes off, carbon dioxide is going to turn into acid, a weak acid, yeah. Or even if you're doing anaerobic, lactic acid, right? Lactic acid builds up. Over here, when we break down proteins that have sulfur phosphorus in them, you're going to have sulfuric and phosphoric acids that come off. And then here, we'll talk about this. I'll show you this too. When we break down fats, you get these ketones, acetone, and some other acids that will contribute to acidity. Usually that's not a problem, but it can be a problem in diabetes. I'll talk about that. So all these things produce acid, and your body's got to get rid of it. So breathing's a real quick way. Your kidneys can pee out hydrogen ions, but you need to, overall kind of acidity needs to be kept down within that range. Yeah, so we'll talk about diabetes real quick, and this something called ketoacidosis. And the deal is this, with the diabetes I'm talking about, your cells, they can't let glucose in. So your cells are awash with glucose in the blood. It's actually at a high level in the blood, but it's like being in that life raft, water everywhere, but nothing to drink. It can't bring the glucose in the cells. So, because the insulin is necessary to carry it in. And so the cells got to burn other things. Proteins and fats, they'll burn the fats instead of carbs. You burn carbs and it's clean. Carbon dioxide comes off. You burn fats and ketone bodies. Ketones are given off. And normally you guys, you can do anaerobic exercise, right? You can do a sprint, something like that, and you get rid of those ketones. They're used as energy. It's no problem. But if you have high levels of ketones, they're acidic and they build up and cause acidosis in people. And look at here, because of diabetes, you can see glucose. You've got tons of it. So you're hyperglycemic. You got tons of glucose out in your freaking blood, but it can't get into the cells that need to burn it. And so the cells, what do? They use whatever energy they can, and burning of fats leads to ketones, which is going to lead to acidosis. Anything urea, this means it's going to be, there'll be acid in your urine. You can even smell a fruitiness to the breath as some acetone comes off. Because it's high in your blood, it's going to come off in your respiratory system as well. Yep, and you're going to have lots of pee and blood in your pee. I want to make sure you guys understand, I mentioned it earlier, but if you're diabetic and you get rid of lots of glucose, you're peeing it out. Remember, you can't take it all back. With the glucose, water is going to come to it by osmosis. So whenever you have substances in your filtrate, your urine, it's going to prevent water from coming back into your body. So sugar can be one thing. So if you're peeing out sugar, you're peeing out a lot of water. So diabetics uncontrolled would pee a lot because the water is going to come with the sugar. And you can even give substances, this mannitol, that also fills up your filtrate and it takes the water with it if you're trying to get rid of water. So you pee a lot if you're going to be peeing out sugar because the sugar is going to keep the water there because of osmosis. So in diabetes like this, or you're burning fat only, you're going to have ketones build up. And it's normally not a problem until it gets to a high enough level, and then you get this acidosis. Okay, so we're going to talk about how we buffer, how we keep that pH in this narrow range. So first of all, acids, a strong acid just ionizes completely, like hydrochloric acid. You put that in water, it completely separates into hydrogen and chlorides. And a weak acid, like carbonic acid, some of it dissociates into hydrogen ions of bicarbonate, but some of it doesn't. So it's a weak acid. It doesn't completely get rid of the hydrogen. Some of it's stays together. It doesn't completely dissociate. Same thing with bases. So acids are things that give off hydrogen ions. Bases are things that give off things that suck up the acid, usually OH, but it can be some other things. So let's talk about acid concentration and how we keep it balanced, definitely. Because a shift either way is bad, to acidic or to alkaline. Remember, because our reactions take place in this narrow window. We normally produce more acid. Yep. So here's the three systems. Buffering, we'll see that with chemistry. Definitely your lungs or your kidneys can get rid of acids or bases. So buffers. A buffer is something that keeps things stable, right? You may bring a friend out on a date or on an uncomfortable situation to buffer so that you have someone to talk to, or that if things get out of hand, they can like calm things down. Strange analogy, but I did it. Buffers in chemistry, I'm sure you put in with your test tubes to keep the pH constant, or other things. Anything can be buffered. Anyway, so the buffering system is chemicals in your body that if you throw a bunch of acid at it, it's going to suck it up and it's not going to let the acid rise. Or we put a bunch of bases, it's going to suck it up, it's going to keep it normal. So buffers will keep things stable. Most important in your body is the bicarbonate, right? We talked a lot about it. Carbon dioxide comes in and it's going to turn to carbonic acid, and then again, it's a weak acid, so some of it will disassociate here. But if you throw a bunch of hydrogen ions into this situation, they're going to bind with any free bicarbonate and they're going to move it this way. Yeah, and so they will buffer this increase in hydrogens, or the opposite, they're going to buffer it the other way. So bicarbonate's everywhere, super important. There's a phosphates system also that's real important inside your cells. Remember, there's a lot of phosphorus there, but throughout your body, where you can see you have this weak acid in the middle that if you had acid, it's going to suck it up and hold on to it. If there's not enough acid, it will release it and make it and bring it back to normal. And then proteins themselves are buffers. Remember we talked about blood and how hemoglobin actually can hold hydrogen ions. Remember we were talking about how to get carbon dioxide back? It can hold on to it, not in the heme, but in the globin part. So if you have a carboxyl group here, it can hold on to a hydrogen or release it. And even this ammonium, the amino group, can hold on to a hydrogen or release it when necessary. So acidity is low, it'll get rid of hydrogen ions to bring it back up. Acidity gets high, it'll suck up those hydrogens and hold on to them. That's what a buffer does. It keeps things just normal. And you can overwhelm these buffers by, if you keep adding acid, the buffering system will be used up and then your acidity will just skyrocket. But this is instant. This is chemistry. This happens really quickly. The other two are slower. And I guess just as an overall something to memorize, to know, is that buffers will change a strong acid to a weak acid or a strong base to a weak base. So these buffers, they will work. They will instantly keep your pH within that range. If it gets some kind of a salt, too much acid, too much base comes in, it will buffers will take care of it very, very quickly. Now, over time, you need to get things back to normal, but the buffers will get it just there, right there. But the other two organs that are so important, in your acidity and your alkalinity, I think you guys know, because I just told you. Your kidneys. Your kidneys can pee out acid or hold on to acid. It can do whatever you ask it to do. And your lungs. You hyperventilate, you dump out the carbon dioxide, your whole body gets, the pH gets higher, you get more alkaline. If I hold my breath, I become more acidic. So instantly the lungs can take care of that. I think instantly, it takes a little bit of time, a few minutes. Kidneys will take, hours like that. The buffer chemical system was instant. Yeah, so hopefully you got this with the respiratory system. You guys instantly, you can affect your pH just by holding your breath a little bit or hyperventilating. Yeah, and remember, this is how your freaking respiratory rate and depth is controlled, right? Remember, it was by the acidity caused by carbon dioxide. Carbon dioxide and the acidity, hydrogen ions, are going to influence your breathing center. So we've circled right around from the respiratory, how it's controlled, to here, like your acidity or alkalinity. Yeah. And your kidneys, and it says here, if you eat a lot of proteins, you're going to have a lot of amino acids. You're going to give off, again, anything with sulfur is going to have sulfuric acid, phosphoric acid. All these things need to be taken care of. And usually your pee becomes more acidic if you eat tons of proteins like that. Yeah. Beautiful. So your kidneys can also keep that homeostasis. So here's the time course. Again, that's important, is that the first line is the buffers. First line, quick, instant. It's just chemistry. And then your body can take time and use respiration and urination to get rid of excess acids or bases. All right, good stuff. So here's our narrow range of life. Beyond that, you'll have conditions, if you vary from that, called acidosis and alkalosis. Each of those life-threatening. Once you get too acidic or too basic, your chemical reactions do not work, and you are your chemical reactions, is what you are, and so you're not long for this world. Don't mean to be so dramatic, long for this world, but again, you have to be in this narrow range. So acidosis is when you get too many acids or you lose too many bases. They're both related, right? Alkalosis is when somehow you take in too many bases or you don't get rid of enough acids. Definitely. So you can think about that. Just drink a bunch of acid or drink a bunch of lye. It's going to, that's not the way to do it. But those things would increase your acidity or alkalinity, right? So when we look at these two things, this is another important point in this lecture. Like acidosis, there's two forms. You're going to see respiratory or metabolic. Same thing with alkalosis. It's very simple. Respiratory has to do with breathing. So respiratory acidosis would be if you had obstruction of your breathing or you stop breathing. Because carbon dioxide would build up, you become acidotic. Metabolic would be other acids, lactic acids, or any kind of acid, but it's via maybe the kidneys are not working right. They don't get rid of enough acids and they build up. Or we mentioned that with ketoacidosis, where you're just burning fat and those acids build up. So something metabolic is something metabolic. Anything but respiratory. Look at that, prolonged diarrhea and vomiting too. I mean, vomiting, you would get rid of the acids in your stomach, but if you have serious vomiting, your intestinal contents are alkaline, and you can get rid of some of it that way. And on the other end too, you get rid of waste that is going to carry some of that alkalinity, that basic out of your intestines. It's going to make you more acidotic. Okay, that all looks good. And then again, alkalosis, respiratory, hyperventilates. You guys are going to get, your pH is going to rise, just period. Yeah, and then metabolic, they look at that, yes. So loss of acids by vomiting, getting rid of that acidity from your stomach, definitely. All right, this I put up for you guys. I don't think, normally even in class, I don't think I would go through it. I don't think I need to, but this is fun for you to take a look at. See, make sure you understand what's going on. It's just one more. We've been through it already. Looking at if blood volume drops because if water volume is going to drop, you're going to have more concentrated solutes, and how that's going to stimulate your kidneys and everything like that. So take a look at that. All right, I will have a little test for you again, like the last one. We'll just be on 2 chapters, the urinary and then the fluid electrolytes. Let's take a look at that.